Hi Tulsa Athletics fans, my name is Kayley Cassaday. I'm a senior soon-to-be graduate outside hitter on the University of Tulsa volleyball team. And I am a mechanical engineering major, and in order to graduate, we have to complete a senior design project. So this year, me and my group mates decided to participate in NASA's Micro-G Next Challenge. So every year, NASA puts out multiple engineering problems that they've experienced on their missions or just in their field, and then they encourage college students across the nation to complete these projects and come up with innovative solutions to these problems. So the problem we selected as our design project is a attachment mechanism for an extension handle and a tool attachment head. So during the Apollo moon missions, their previous design would get clogged up with moon dust, which is different than Earth dust, surprisingly. So they encouraged us to figure out a solution that is dust tolerant specifically, and we'll talk a little bit about our designs. So here are my group mates.
Hi, I'm Georgia Hilburn, and I'm from Shreveport, Louisiana.
I'm Caroline Port. I'm from St. Louis, Missouri.
Hi, I'm Sherry Malik, and I'm from Broken Arrow, Oklahoma.
Hi, I'm Bethany Wilson. I'm from New York.
Hi, I'm Jack Oxley. I'm from Flower Mound, Texas.
Hi, I'm Michael Lester. I'm from Collinsville, Oklahoma.
Hi, I'm Eddie Lichty. I'm from Tulsa, Oklahoma.
And I'm Kirsten Erickson, and I'm from Overland Park, Kansas.
Now that I've introduced the project to you, I'll have my group mates explain a little bit more about the details. So, Georgia, how did our initial brainstorming process look?
So we got really lucky with a group of very smart people, and so we all came up with about 2 or 3 ideas, brainstormed, presented them to each other on a slide, and brainstormed the pros and cons. We also did a lot of research on what the conditions we would be designing for on the lunar surface, and we eventually landed on a switchable neodymium magnet. It works like so. You turn it on, and it automatically produces a magnetic force, and then you can turn it off, and the magnet comes off really easy.
All right. Jack, Michael, and Eddie, do you mind explaining how our current prototype works?
So this comes in a few parts. Again, this is an extension handle, so there will be a handle on this side that astronauts will use to actuate it. And there will be a scoop, a sample collection tool on this side. So the idea is that you insert the tool like this, and this will be made out of metal in future prototypes. And that magnet that Georgia previously introduced will be housed inside of this assembly. So the handle that was turned to turn the magnet on and off will be actuated by this here.
So it's important that all of the components in here are sealed off from the lunar environment. So we're going to introduce seals on the edges of this collar here to ensure that no dust can ingress. And then it also is important to note that this is our rapid prototyping stage. So then we're going to go through a lot of iterations with the plastic, but then eventually all this will be metallic material.
It should be prioritized that this is what NASA is looking for, the attachment specifically, but there will also be a different tool attachments and an extension handle, which will make it much longer.
So, Kirsten, is this our final design?
No. So throughout the semester, we will have multiple design reviews with NASA and our class, our senior design class, and we'll get lots of feedback about ways that we can improve our design in terms of manufacturability, cost, overall design, ergonomics, and safety. And so throughout the semester, we'll be iterating our design, and our ultimate final product that we manufacture for NASA will be fully made out of metal, and it will have the tool and the extension handle included as well, so that the astronauts can test it.
And finally, Caroline, what do we get to do with this project?
So we're going to get to go down to Houston on the week of June 5th, and we get to test in 2 different environments. The first is the NBL. It's the Neutral Buoyancy Laboratory. It's a really large pool that's pretty deep, where they do a bunch of astronaut testing. And we're also going to get to test in a lunar simulation environment, which will be super fun. And alongside that, we also get to go work with the Marquette School Girl Scout troop in order to do an activity and outreach to bring them an engineering challenge, to allow them to really think like an engineer and really see this problem that we're facing and get to test different solutions as well.
All right, TU fans, I hope you enjoyed learning about our senior design project. And we do have our final design review on April 24th. It is open to the public. If you would like more information, please reach out to athletics. We'll get the times and date to them. And I appreciate you guys for watching. Reign Cane.